See a few of you in here already, and I didn't want to. I would wait for more people to show up, but this lesson for today is only going to be 2 questions. It's going to be number 3 and number 4. And if you were with me for lesson number 9, you guys will notice that it's pretty much the same thing. I just got to set it up, make sure you guys are good for the homework, and we'll be good to go. Okay, so what I'm about to show you guys is going to help you guys out for homework number 9 and for homework number 10. Number 9, I think I set the due date for tonight at 9 o'clock, if I'm not mistaken. So get it to me when you can. But there's not much that we're going to have to do today, because what we're going to do in exercise number 3 is kind of similar to what we did in exercise number 2 yesterday. Exercise number 3 is just like this question right here. Very, very similar. Obviously different numbers, and you guys will see how we're going to graph this out. So before we do any graphing, the first thing you guys should always look for are asymptotes. So I'm going to start off by finding the y equals asymptote first. This will be the vertical asymptote, because that's exactly what we did yesterday in this top problem. Hold on, Notability just crashed on me. All right, so lesson 10. So this part right here, that y equals AC, that will always find your horizontal asymptote, because it's y equals, it's going to go sideways, so it's going to be horizontal. So the first thing I'm going to write down over on the side is horizontal asymptote. And in order to find the horizontal asymptote for this specific problem, because of the way it's set up, we're using that y equals A over C. So in exercise number 3, we just need to find what the A value is and what the C value is for the horizontal asymptote. The A value is just going to be the very first coefficient, which in this case is 1. And the C value is the first coefficient on the bottom, which is 3. So the horizontal asymptote for this problem is just y equals 1/3. And again, this is not allowed to happen. So when we go to graph it, that's where our little dotted line is going to be. Okay, so horizontal asymptote is just using that formula. The vertical asymptote, this one's a little bit easier because this is something we've been doing for a long time. This is where the function is undefined. So I'm just going to put in undefined question mark. We have to figure out what x value makes it so this does not work. So in order to figure that out, we just have to take our denominator and we have to set it equal to 0. And what we're going to do is we're just going to solve it. So what I'm going to do is subtract the 3 over to the other side. We'll have 3x is equal to -3, and then we're just going to divide it all by 3, and it's going to come out to be -1. So again, these are asymptotes. They do not work. So if I want to find the domain and range, just like I did yesterday, I'm just going to do those squiggly brackets. So for this one, I'm going to have all y values work, but y cannot equal 1/3. And in the second one, I have all x values work, but x cannot equal -1. Oh, I ran out of room. I'm hitting the little arrow. All right. So now that we have that, we can graph it off to the side. So I'm going to graph my x and y axis. Come on. So the y cannot equal 1/3. This one's going to be a little tricky to graph because it is a fraction, and we don't normally tend to graph fractions all that much. But y being 1/3 is going to be like right about here. It's going to be just above the x-axis, not necessarily halfway up. And I'm just going to draw a little dashed line going all the way across on both sides. So that is one asymptote. Our graph cannot cross y equals 1. I'm sorry, y equals 1/3. We also have to graph the vertical asymptote, which is at x equals -1. This one's a little bit easier because -1 is right on our graph. So I'm going to draw in my vertical going up and down. And that is at x is equal to -1. So we're not allowed to have answers there. So the easiest part, this next part, because you guys are just in Math 12, I told you guys you could just type this into the calculator, and you're just going to figure out which way the graph is going based on what your calculator shows. So I'm just going to go into y equals. I'm going to clear that out. I'm going to type in my fraction of x minus 2 over 3x plus 3. And then I'm just going to hit graph. Now, again, when you guys go to graph it, if you're not seeing what I am seeing, I mentioned this a couple times in our lessons now. I'll mention it again just to make sure you guys are good. You're going to push the zoom button, which is down here. So I'm going to press zoom, and then you're going to go down and you're going to press Z standard. And once you press that Z standard, you should see a screen like mine. If your calculator is still messed up, just make sure to email me, because sometimes the iPad calculators can be finicky, and I know how to fix it. It's just hard to explain unless I'm actually like talking with you, or I could just send out an email of how to do it. Okay. So in this one, it shows that our graph is going to be up here in the top left. I'm just drawing it the best I can. We don't actually have to plot all the points. And it looks like it's also going to be in the bottom right. And we just have to make sure that we show that it is not crossing those dashed lines. And that's it. So we found the two things that we were supposed to for this problem. We had to graph it, and then we also had to state the domain and range. And that is all there. So homework 9 had a lot of questions like these, and I think I put 2 questions on homework 10 on here as well. Okay. Last question, going to be very, very similar to what we did. This is kind of like 2C. So it's going to be like this h of x equals -2 over x minus 5. It's going to be the same kind of setup. So first thing I'm going to do is find domain and range. I always start off with the horizontal asymptote because that is the trickier one. I like getting the hard one out first. So when you're looking for the horizontal asymptote, in this case, you're going to notice it's not just a fraction. You have a fraction and you have that plus 3 at the end. That plus 3 at the end is known as your k value. So if you want to find a horizontal asymptote for a problem like this, you just have to state the k value. And that's it. So the k value is always going to be that last number unless there's no number there. Okay. And then in that case, you could just say it's 0. If you have x's on both top and bottom, then you have to do it like we did in exercise number 3. The other part, the vertical asymptote, that's like what we just did in the last problem. It doesn't change. You are looking for where it's undefined. And again, what is going on? Again, when you guys go to find where it's undefined, you're just setting the denominator equal to 0. And it's pretty easy to do. You're just moving the 4 over to the other side, so you have x equals 4. And now we just have to state what that domain and range is going to be. So it's just doing the squiggly bracket, all the y's, but y cannot equal 3. And in this one, all the values for x, but x cannot equal 4. From here on out, it's just like we did in exercise number 3. All the steps are going to be exactly the same. So I'm going to draw in my x and y axis. That is not in the center, I don't think. At least it looks off. And just like that last problem, I'm just going to draw them in. So I have y cannot equal 3. So I'm going to go up to the 3. I'm going to put in my dashed line at 3. I also have to put in my x cannot be 4. So I'm going to go over to 4, do the same exact thing. And to make life easier, we're just going to type it in the calculator. Oh, my calculator's not popping up. So I'm going to go back into y equals. I must hit second. There it goes. So I have, it looks like it's negative. No, negative. There it is. Negative 1 over x minus 4. It doesn't matter if you put the negative on the outside or if you put it to the top of the fraction. It's the same thing. Plus 3. I'm hitting graph, and it looks like in this case, so again, when you're looking at the graphs, just remember that the horizontal dotted line will never show up on the calculator. It only shows the vertical one. So you're just going to have to kind of eyeball to make sure that what you did was correct. And it does look like this graph, if I were to be right up here, it does look like it's at 3, which is what we stated down here. So it's okay. So just like the other page, it looks like it's going to be the top left. So I'm just going to try to draw it the best I can. Make sure I put those arrows on. And it looks like it's also going to be the bottom right. And there we have it. What we did is we found the domain and range, and we graphed our function. These are just graphing rational functions. Again, these are called hyperbolas or hyperboles. I think it's hyperboles if you make it plural. Okay. So I have nothing else to show for today. I see there's a few guys in here. I know there wasn't much chatting today, but no big deal. I think I got back to everybody that was in here that emailed me yesterday. So take a look at whatever I emailed back to you. And if you still got questions, just let me know and I can help you out. All right. Other than that, I am calling it quits for today because I am dead tired. I've been going at it on Zoom since like 8 o'clock this morning. So between Zoom and the lessons, it's just draining. So I hope you guys all have a wonderful evening. I will see you guys tomorrow. Adios. See you, Hannah. See you, everybody else. Bye.